Hi everyone, Mr. Yates here. So today we're going to be going through the Year 11 2019 practice exam for Year 11 methods. And this is going to be a video in three parts. The first part, we're going to be going through the calculator free part of the exam. And in the second and third parts, we're going to be going through the calculator allowed part of the exam. So let's get started. Now, first up, we've got a question about a line segment that connects these 2 points, and it is the diameter of a circle. And we need to determine the equation of the form of the circle in this particular form. So let's get going on that. And one of the things I actually like to do in these situations is just to draw a really quick little diagram, just to get an idea of what's going on. So 2 points form the diameter of the circle. That's at -2, -3, so it's about there. And another one at -2, 5, so that's going to be about here. And this is going to be the diameter of a circle. So let's see if I can draw a roughly adequate circle there, something like that. So, so that's roughly what our circle is going to be like. Now, in order to get the equation of the circle, we need to find the center. Now, obviously, this has an x-coordinate of -2. We're quite fortunate in that the x-coordinates are lined up. We don't have to use any trigonometry to work anything out, or Pythagoras to work anything out there. And the y-coordinate is going to be halfway between these 2 points, and that is a 5 and a -3, so halfway between those is going to be at 1. Or we can add those together, 5 take 3, divided by 2, that also gives us our 1. So once we know the center of the circle, we've got to put it in our circle form. So that's going to be x plus 2, because remember that we've got to invert the sign for that one there. X plus 2 all squared plus y minus 1 all squared. And that's going to be equal to the radius squared. And the radius here is 4. So that's going to be 16. So that's the equation of our circle, but that's not the form we want it in. We want to expand it. If we expand it, we get x squared plus 4x plus 4. And the other one, we get y squared minus 2y plus 1 equals 16. We want to make sure to get all of our constants on one side. So I'm going to subtract 5 off the left side, subtract 5 off the right. We end up with x squared plus 4x plus y squared, take 2y, equals 11. And that's our answer. Now I've got the solutions just here, just to make sure I'm not making any really silly errors. And looks like I've got that right, so that's great. So that's our answer there. I'll leave that, just go back up there, just so you can see that. Now, on to question 2. Determine the gradient of this curve at the points where it crosses the x-axis. So first up, we've got to find where it crosses the x-axis. So it's going to be a curve that looks a little bit like this, and we expect it to cross the x-axis at 2 points. But let's do that first. So when we've got an equation like that, we want to factorize it. And to factorize it, we need to find out what 2 numbers multiply to -40 and add to -3. So you can start listing factors of 40, but it's pretty obvious here that we've got 8 and 5. 8 times 5 is 40. One of them is going to be negative. We've got a negative addition here, so the larger one is going to be the negative one. So we end up with x minus 8, x plus 5, and we want that to be equal to 0 when it crosses the x-axis, so x is going to be 8 or -5. So those are our 2 points where it crosses the x-axis. So, but we've got to determine the gradient of the curve at those 2 points. So let's differentiate it. dy by dx is 2x take 3, and we've got x equals 8. dy by dx is going to be 16 take 3, so that is 13. X equals negative 5, that's going to be dy by dx equals 2 times negative 5 is negative 10, minus 3 is negative 13. Now, just as a reminder, all of our parabolas that we've got are symmetrical. They're symmetrical right down the middle. So we do expect the gradient on one side, so this one is going up. We do expect the gradient on this side to be exactly the same as the gradient on that side. So the fact that we've got the same number there is a nice little sanity check to let us know we're doing the right thing. Okay, so just a sec. There we go. So next up, we've got simplifying this. Now this is easier than it looks because we've got the same thing that's a negative on the other side. And when you've got the same thing that's a negative on the other side, the same thing on that side, it's just a difference of two squares thing. So all we've really got to do is 3a times 3a, that's 9a squared. Then it's 2 root a times 2 root a. It's going to be negative because there's one negative in there. That's going to be 4a. And that's our answer. Pretty straightforward. We could have multiplied the other ones out, but I already know that these are going to cancel out to be 0 because they're equal and opposite. And so that's all we need to do there. Really easy, 2 marks. Solving this equation, 8 to the power of x equals that. Now the hint we've got here, these are all powers of 2. And it may be helpful to list your powers of 2. So we've got 2, 4, 8, 16, and 32. So this is 2 to the power of 1, 2, 3, 4, and 5, which is going to be useful because we've got that 32 up there. So 8 is 2 to the power of 3, and that's being raised to the power of x. Remember that root 2 is 2 to the power of a half. Root 30, 1 over 32 is 2 to the power of 5. And we can start rearranging and simplifying this. Remember that 2 to the power of a half, or you can move that, times 2 to the power of negative 5 equals 2 to the power of 3x. These you add together, so we get 2 to the power of 3x equals 2 to the power of negative 4.5. And that then simplifies to 3x equals negative 4.5, which is obviously x equals negative 1.5 there. And there we've got our answer. So x is negative 1.5, and we just had to rewrite everything as a power of 2 in order to rearrange that and just use some of our index laws. Next up, we've got a sketch of a graph y equals 2 to the power of 1 minus x. For a question like this, we know it's an exponential, so it'll be looking something a little bit like that. But in all honesty, one of the easiest ways to do this is to just substitute. And we always start, the best place to start is at x equals 0. So if x is 0, 2 to the power of 1, that's 2. If x equals 1, 1 take 1 is 0, 2 to the power of 0 is 1. There we go. Watch your scales as well. The horizontal scale is not the same as the vertical scale. That should be 2 to the power of negative 1 is going to be a half. And then we sort of see as well, if x is negative 1, we've got 2 squared, which is 4. And we should go to 8 up there. So what we actually end up with, and what we should try and draw, is a line that is always increasing. Try and make it so it's always increasing if you can. And it is a smooth line, hopefully smoother than what I was able to draw here. There we go. And it should look a little bit like this. And it helps to put little arrows on the two sides there. It should not cross the x-axis if you can avoid it. And yeah, it should basically, it's halving in value each time. Now it doesn't quite look like this, because this one increases as we go to the right, but we've got a negative x value, so we expect it to be flipped in the y-axis because there was a negative x in there. That's one of our transformations. But this one is actually really easy to do if you just do substitution and go from there. You don't even really need to know any of the nature of flipping over the x-axis or over the y-axis. but it is helpful if you know that, so that explains that you have gotten the right answer here. Okay, next up, we've got a small body. A is moving along a straight line, and its displacement is given by that. Now, thing to note is we have centimeters here. So you should make sure to answer all of your questions using centimeters as the units. The velocity of A when t equals 3, we want to differentiate. Dx by dt is our velocity, and that is 3t squared, take 6t, and the 5 disappears. T equals 3, v equals 3 times 3 squared, that's 27, 6 times 3 is 18, that's just going to be 9 centimeters per second. We've got centimeters and we've got seconds as our 2 units, so we've got to say that. Pretty straightforward for 2 marks. Now, the displacement of A relative to O at the instance, there's a little s in there to let us know that there might be 2, that is stationary. So to be stationary, the velocity's got to be 0, and we already know that that's 3t squared, take 6t. When's that equal to 0? Well, we can take out a factor of 3t, and that tells us that it's stationary at t equals 0 or 2. These are both solutions to that equation. So, if t equals 0, we've got our times, we've got to work out the displacement. X equals, and t equals 0 is very easy to put in there. X equals 5 when t equals 0. And the other one is x equals t cubed, that is 8. Take 3 times t squared, so that's 3 times 4 plus 5, which is 8. Take 12 plus 5, or 13 take 12, which is 1. And let's put in our units. So, and 1 centimeter. And we'll put in when t equals 2. I'm just going to double check that just to make sure I haven't made a silly error, because I don't want you to waste your time scratching your head working out what I've done wrong. So, yep, that's right. Now, last one, small body B has this velocity. So this is one where we have a velocity and we need to work out the displacement. And so when t equals 2, it has a displacement of 3 centimeters. So we need to integrate 6t squared plus 2t minus 3. What we do is we increase that by 1, t cubed, and I like to just do that to make sure that I'm doing it correctly, even though that is a very easy thing to sort out. Remember, we've always got a plus c on the end. So let's simplify that. That's going to be 2t cubed plus t squared, take 3t plus c. And we know that it equals 3 when t equals 2. So let's solve that. 2 times 8, which plus 4, take 3 times 2 plus c equals 3. That is 16 plus 4 minus 6 plus c equals 3. 20 take 6 is 14 plus c equals 3. C is going to be negative 11. So remember, now that we've gotten C, it doesn't ask us to find C, it says to determine an expression. So we've now got to go back up to the original equation and write, or what we worked out is going to be 2t cubed plus t squared, take 3t minus 11. So, so we need to say that as our final solution. And it looks like I've gotten that right, so that's good. It's easy to make little mistakes in these ones. So let's go to the next one. So we've got Pascal's triangle or otherwise determine 4 choose 2. Now the original equation is 4 factorial over 2 factorial times 2 factorial, or we can use Pascal's triangle, and in fact I'm just going to put Pascal's triangle here because we are going to need it in the next question anyway. So 4 choose 2, remember that this one here is 4 choose 0. So 0 is always the first one, and just like this one is row 0. So remember that Pascal's triangle uses zeros a lot. So this is row 1, row 2, row 3, row 4. Row 4, that's element 0, element 1, element 2. It's going to be 6. Or 4 factorial is 4 times 3 times 2 times 1. 2 factorial is 2 times 1, and then another 2 factorial. 2 times 2 is 4. These cancel out. The ones are unimportant anyway. 3 times 2 is 6. That's another way to get it. And they're both the same answer. So when we expand that, this is, again, pretty straightforward and even more helpful because I've already done Pascal's triangle up there. That's going to be x to the power of 4 plus, and remember we've got to take this number down, 4x cubed. Fortunately, we've only got a 1 here, and no matter what power that is, it's always going to end up being 1, so it's not going to change it. So this is actually really easy to write out. 6x squared plus 4x plus 1. There we are, easy. So determine the equation of the tangent to the curve of this at the point where x equals -2. So to get the tangent, we've got to work out the derivative. So let's differentiate it. That is 4x cubed. This one is 12x squared. This is 12x, and then that is 4. So if x equals -2, dy by dx is going to be, now this is going to be -8 because it's an odd power, so the negatives don't cancel out. So that's going to be negative, I'm just going to do 4 times 8, just move the negative out the front. This is going to be a positive, so it's going to be 12 times 4. This one's going to be a negative, minus 12 times 2, plus 4. Make sure my face isn't over that. So that's going to be -32 plus 48, take 24 plus 4. Now when we're dealing with these sorts of ones, I do like to group together the positives. So I've got 52 and group together the negatives. 32 plus 24 is 56, and that gives us -4. So that one actually ends up being a lot easier than trying to jump back and over our negatives there. So that's our gradient. So that's going to be dy by dx. So what we need to do next, there's a lot to this one. The next thing we need to do is find out the y coordinate. That's actually pretty easy. -2 plus 1 is -1. -1 to the power of 4 is 1. So it's we don't even have to. It would be it's much easier to do this than to try and do in the original equation. So anyway, we've got y equals. Oh, sorry, we've got a y value. We know our y. It's going to be. Oh, sorry. Y equals mx plus c. Y is going to be equal to 1. M is -4. X is -2 plus c. That's going to be 8 on this side. 1 take 8 gives us that c is equal to -7. So the equation is going to end up being, and I'll put that up here, y equals -4x take 7. Now there's a lot to this question. It's very easy to make a little mistake. So I am just going to double check. Yep, I got that one right. And that is our final answer there. So there we go. Very easy to make a little mistake as we do these ones as well. So just be careful with it. We're up to question 6. So including this, there are just 3 more questions. Now we've got some trigonometry. Tan of 2x equals root 3. Now whenever we've got 2x in here, I like to actually change our range to include that 2x, which means that our range goes up to 2 pi. And a range of 2 pi is much easier to deal with because that's a full revolution. So where does this equal root 3? So it equals root 3 when 2x is equal to 60 degrees. But that's not the only time. So that's going to be 60 degrees, or rather, let's not do degrees, let's do radians. That's going to be pi on 3 radians. That's a third of the way to the pi distance, which is 180 degrees. So this is pi on 3. Where's the other one? It's down there. This is another pi on 3, or one more than, or pi plus pi on 3 is the actual angle. So it's going to be 4 pi on 3. But this is 2x is equal to these, not x. So I've got to divide these by 2. So x equals pi on 6, or divide this by 2, 2 pi on 3. And both of these should be within this range between 0 and pi, and they both are. Great. So that's all there is to that one. Dealing with this 2x in here can be a bit frustrating, but we can still work it out there. Okay, now here we've got the dreaded angle subtraction formula. 2 cos brackets x minus 60 equals root 3 plus cos x from 0 to x to 360 degrees. Now, fortunately, we've got degrees, which I find a bit more intuitive, but all the same, let's work this out. Now, this is the double angle formula. Go into your formula sheet if you haven't memorized it, and make sure you use brackets carefully. So I'm going to put a bracket right out the front of this and expand this in here. That's going to be cos x cos 60 plus, so remember it's the opposite sign of what we've gotten there, sine x sine 60 degrees equals root 3 plus cos x. Now, what's cos of root 60? That's a half. What's sine of 60? Root 3 on 2. So 2 times, and I'll just actually simplify them down here. So that is half cos x plus root 3 on 2 sine x. Now, when's this going to be, or what happens when we multiply everything by 2? The divided by 2's cancel out on both of these, so we end up with cos x plus root 3 sine x equals root 3 plus cos x. Now, fortunately, we can subtract cos x from both sides. After we've done that, we can divide by root 3 on both sides, so we're left with 1. When is sine x equal to 1? Well, it's only equal to 1 at 90 degrees. That's the only time. Remember that our x-coordinate, or our y-coordinate rather, is what sine is on the unit circle. The only time it's at 1 is up at the very top. So x equals 90 degrees. Oh, x equals 90, yeah, 90 degrees. There we go. So there we have it. Next up, we've got a graph. A and B are positive constants. That's a little trick. Oh, that's a little thing right here. When we add something inside there, that means we're shifting to the left, not the right. So that gives us a little bit of a clue about what's going on. So let's actually work out how it's been shifted to the left. So it's been shifted, this is 30 degrees up here, so it's actually been shifted by 10 degrees left. But let's also work out what the period is. So it looks like the period goes from -10 to 80, or the period is 90 degrees. This is 1/4 the length of the normal period of 360 degrees. So we know that A is equal to 4. Now, when we have our equations, we should remember that what it actually is 4 brackets x plus 10. And we've actually got the expanded version out there. So what it actually will end up being is sine 4x plus 40. It's very easy to fall into that trap. But if we're careful, then we spot that it's actually going to be plus 40 in there, not plus 10. That's a very easy one to mix up though. Okay. So this is my least favorite question in the entire calculator free section because it's so easy to mess up, but let's have a look at it anyway. And it's extremely mean as well. But we determine the coordinates of all stationary points on this curve. So what's a stationary point? It's where the derivative is 0. So we've got to differentiate this. dy by dx equals 4x cubed plus 4x take 8. So we want to find where that's equal to 0. Now to make my life easier, I'm going to divide everything in here by 4. We can do that without having any real problems. So I've got x cubed plus x minus 2 equals 0. That's a much easier equation to work with than having to work with this one we've got up here. And what we want to find is factors of this. Now, whenever we're finding a factor of a cubic and they haven't given you the first factor, we just want to try a few things. So the first thing to try is x equals 1. If it's x equals 0, it should be obvious, but we're going to try x equals 1, and that's going to give us 1 plus 1 minus 2, which does equal 0. So x is x minus 1, or x equals 1 is a factor. So that means we can x minus 1, and we've got x squared plus bx plus c. Now, we've got to work out what b and c are. We know that the first term is going to be a 1 in there, and we know that because the highest term here is x cubed, so it's got a coefficient of 1, so we know that there's only one way to get that, so I don't need to worry with that. C is the next easiest one to work out. We just do -1 times c, or negative c, is going to be equal to this number here, equals -2, so c equals 2. Easy. The next one to work out is, I like to work it out by doing this one. So we do, let's just scroll down slightly. So we do bx squared take x squared. Now there's actually no x squared term in here, so it's going to be equal to 0. And so b is going to be equal to 1. So x squared take x squared is 0. Or you can take these out entirely and just do b minus 1 equals 0. B is going to be 1, which means what I've got is x minus 1, and we've got x squared plus x plus 2. Now, the next bit we've got to work out is, what does this factorize to? And you may start scratching your head, what number adds to 1 and multiplies to 2? And you may very well start to go, I can't work this out, I'm just going to use the quadratic equation. But to start off with, I'm going to check the discriminant. So the discriminant is b squared minus 4ac b squared is 1, so it's going to be 1 squared, which is just 1. A times c, it's going to be 4 times 1 times 2. That's equal to -7. And with a negative answer, we have no solutions. So there's only one solution. At x equals 1. And now that we've done that, we've worked out the only solution is at x equals 1. We can throw that into our original equation. So we get 1 plus 2, take 8 plus 9. 12 take 8 is 4. Only stationary point is at 1, 4. So make sure you actually answer the question at the end of it. It will be a real shame to go through all that work out that that's 4 over there, and to not actually answer the question, which says determine the coordinates of all stationary points. I'll just make sure I've got that right, because there's a lot of ways to get this wrong. Looks like I have, and there it is. This is an extremely difficult question, and there are lots of ways to go wrong with it. It's worth 6 marks, and it's very easy to just fall down right out the gate and only be able to get 1 or 2 marks out of it, because it's got so much stuff going on. Okay. Next up. An arithmetic sequence has a recursive equation given by this. It has a third term of 40 and a 10th term of 12. This is just the general recursive definition anyway. We don't really need to know much about it, just need to recognize. But the third term is 40. The 10th term is 12. So it has done 7 differences to get from 40 to 12. So what I'm going to do is do the latter minus the former, and that gives us -28. It's done 7 differences between 3 and 10, so I'm going to do -28 divided by 7, and that is -4, which is our difference. There we have it. So now that we know that -4 is our difference, we can find that term 2 would be 44. And term 1 would be 48. So A, our first term, is 48. And we subtract 2 each time to go to the next terms down. And there we are. We've got D equals -4. Let's make that a bit of a neater circle. And A equals 48. Those were our answers. Determine T 2019. That's going to be T 2019. That's equal to A plus N minus 1D, which is, I'll just write the general equation here instead of T 2019, do Tn. So T 2019 is equal to 48 plus, and I'm just going to put 2018 times -4. So the easiest way to go about this is to just do some good old-fashioned short multiplication. 2018 times 4, I'm not going to bother with the negative there, 32, 4, 7, 0, and 8, 8072. But remember, that's a negative number. And then we do 8072, and I'm going to do subtract 48 and then flip the signs afterwards. So that's going to be 6, 12 take 8 is 4, 6 take 4 is 2, 8024. So just to finish it off, just to make sure that the person who's marking understands what you're doing, just write down that there. So term, make doubly sure I've got this, because there's lots of little ways to get this wrong. Oh, yeah, and I did in fact get that wrong. That is negative. That's a negative number in there. So yeah, it's really easy to make a little mistake when we go through there. So that's my first little mistake. And that is a really easy mistake to make. And fortunately, It's only at the tail end of the exam, so I'm fine with that. That's why I've got these answers on the side, just to make sure I haven't done something silly. Now, some of the first m terms of the sequence is 200. What's m? So we want Tm, and that is going to be n. It's usually n on 2, but m on 2, 2a. Let's just get that formula here. 2a plus m minus 1 d. But we've got some numbers we can put in here. We've got 200 equals, and m is what we're finding out. A is 48, so that's going to be 96. Plus m, we don't know, so we've got negative 4 out the front. Negative 4m plus 4. What's, we got 96 plus 4. So what we end up with is 200 equals m on 2, 100 take 4m. We can divide both of those by 2. We end up with, and I'm going to put the m in there, so we've got 100m, sorry, not 100m, 50m, because we divided it by 2 there. We've got 2m squared, or negative 2m squared. So that's just negative 4m squared divided by 2. That's 50m. And we can, I'm actually going to put take 200 over here. Now I've done that because this is a polynomial. Now I'm going to divide everything by negative 2, so I've got a monic polynomial here, a monic trinomial. So that gives me 0 equals m squared take 25m plus 100, dividing everything by negative 2, flipping the signs. What two numbers add to negative 25 and multiply to positive 100? They're both going to be negative numbers. So because they're both negative numbers, then it's going to be 20 and 5. So it's going to be, or negative 20 and negative 5. So it's going to be m take 20, m take 5. So 0 equals that, which gives us m equals 5 or 20. So we've got two answers there, which is kind of what we expect because it did say values of the integer constant m, but we did have to factorize to work that out. So yeah, that one is a tough one. And it's the very last question. I think that 3 marks is a bit harsh for how much effort that this one actually requires, but it is the last question of the test, so you sometimes expect that. Anyway, that's the end of the calculator free part, and next up we're going to do the calculator allowed part. Okay, bye.